Alright guys, so what we're starting today is the last section in chapter 1, 1.7. We're going to do it in two parts. So this first part, what we're talking about is rewriting literal equations. Now an equation that has two or more variables is called a literal equation. To write a literal equation, solve for one variable in terms of the other. So it's almost like we're solving the equation like we've done in the previous chapters where we had, say, 6x plus 7 equals 4. We're going to still solve it for x, but instead of having just 7, we could have 7y or some other variables. But our processes that we're doing and the processes we've done are going to be the same. So when we look at this here, 3y plus 4x equals 9. 3y plus 4x equals 9. And they want us to solve for y. So we're going to solve for the value of y, just this value here. Well, the first thing we want to do is we want to get those variables by themselves. So to get them by themselves, well, what we need to do is we need to get any of the other terms to the other side. So what I'm going to do is I'm going to subtract 4x from both sides. We're going to subtract 4x because 4x minus 4x will cancel, leaving us with 3y on the left side equals, well, 9 and negative 4, or 9 and 4x aren't like terms. And because they're not like terms, we just write it as 9 minus 4x. We keep them separate. Because again, the only way that they can be like terms is if they have the same variables, and they don't. So what that leaves us with is this right here. 3y equals 9 minus 4x. So we have this equation. Now y isn't completely by itself. We have the 3 with it. So what we're going to do is we're going to divide by 3. Because if I divide by 3, it will get it by it. So again, so what we're going to do is we're going to divide everything by 3 because 3y divided by 3 will give us y. Now we're going to divide each one of these terms because when we do this we have to divide each term by the number. So 3y divided by 3, well the y, 3 and 3 will simplify to 1, leaving us with just y equals, well 9 divided by 3 is 3 minus, well 4 doesn't divide by 3 so we have 4 over 3x. And that's our answer. We solved this equation for y. And the way that we solved it for y is we got it by itself. And that's all we had to do for this here. So let's look at the next one. Solve this literal equation for y. So again, we're solving it for y. So we have 4x minus 7y equals 12. So again, we got to get y by itself. Well, the term with y is our 4x. So again, just like before, we're going to subtract 4x from both sides. So 4x minus 4x will cancel, leaving us with negative 7y equals 12 minus 4x over here. Now at this point here, y is still not by itself. So to get it by itself, well, we need to divide by the term in front of it. And the term in front of it is negative 7. So we're going to divide everything by negative 7. Because negative 7 divided by negative 7 will cancel out or simplify out to 1. So we're just left with y equals, well, 12 divided by negative 7, 12 over 7 won't reduce, so we just have negative 12 sevenths. Well, the negative and negative here with the 4x, negative 4x over negative 7, well, the negative and negative will make a positive, so we have plus. 4 over 7 won't reduce, so we're left with negative 12 sevenths plus 4 sevenths x on the right side and y by itself on the left. And that's all we have to do for this here. So sometimes the fractions won't always simplify out. Sometimes they will. Sometimes we'll just have two numbers. But that's all we have to do for this here. Now this here is another example of solving literal equations. Now when we look at this here, we'll notice that we have two variables, two of the same variable. We have x and x here. Three x plus 5x z. Now what we have to do here, and since we're solving for x, we got to get x by itself. What we're going to do here is we're going to do a special kind of move. We're almost going to do the opposite of distributing. We're going to do the opposite of the distributive property. And what we're going to do is we're going to factor out an x. We're going to pull an x, or divide each of these terms by x, and pull it out front. So if I divide this by x, well, the x and x will simplify, leaving me with 3. And if I divide this by x, well, the x and x will simplify just like they did it here, leaving me with plus 5z. And the reason this works is because if we were to multiply it back out, we're not going to, but if we did multiply through back out, we would end up back with what we started with, 3x plus 5z. Now the reason we do this, the reason we did this step here, is because we want to get x by itself, or get closer to it, because now I have x times this here, this whole term here. So I have x times 3 plus 5z. So I went from having 2, because I had 2 x terms, to now having just an x term. There's only one. And what that means for me now is that I can get it by itself by dividing both sides by 3 plus 5z. And these here would cancel. And over here I have 3 plus 5z. So on the right-hand side, when I did that, I'm left with x. And on the left-hand side, I'm left with y over 3 plus 5z. So here it gets a little bit more complicated, but not a whole lot. It's just knowing what steps to do. So we're still going to look at another example of this here, another type like this here, this 3w plus 4wp. 3w plus 4wp equals a. Now again, what we're solving for is w. We're trying to solve for w. Now since we have w in 2 spots, we're going to do again that opposite of distributing property. We're going to factor it out. That means we're going to pull it out of both terms. I'm going to factor it out, well, or I'm going to divide each one of these by w. Well, w and w here will cancel out, leaving me with just 3, plus w and w cancel out here, and I'm left with 4p. Now this factoring out, what I'm talking about here, factoring out, are the opposite of the distributive property, only affects this one side. It's only going to affect this side here. It's only going to affect that side here, because again, I'm still pulling it out. It's right there. It's right there. So I haven't changed the left side of this equation, because I still have that term w, and if we were to multiply it back through, we would end up back with what we started with, this here. So it hasn't changed the overall equation. It just changed how it looked. And what that's done is it's given us a w term. We only have one w, one of those variables, on the left side. And what I can do now is I can divide by 3 plus 4p, because when I divide by 3 plus 4p, these would cancel, leaving w by itself. And now what I do to this side, I have to do to the other. And so what I'm left with is w equals a over 3 plus 4p. And that's our answer. Now, I'm not going to do as much of those other ones where we have 2. I want to do some more of these here with 1 variable. We're only solving for this here, just y, where y doesn't show up more than once. Now we look at this here, 3y minus x equals 9. We want to solve for y, so we want to get y by itself. So the first thing I need to do is I need to move anything that's added or subtracted from y to the other side. So we have minus x. So what I'm going to do is I'm going to add x to both sides. So if I add x to both sides, these here will cancel, leaving me with 3y equals 9 plus x. So, so we have 3y equals 9 plus x. So again, y isn't completely by itself. We have 3y. So what we're going to do is we're going to divide each of these terms by 3. So we'll divide each one by 3. And the reason we do the division of 3 is because 3 and 3 will simplify, leaving us with y by itself. And we have y is equal to, well, 9 divided by 3 is 3. So we will get 3. Plus, well, x won't divide by 3, so we can get x over 3, or 1/3 x. And that's our answer. That's all we have to do for this one here. Now looking at this one here, so again, we're solving for y. So we don't always solve for y, but these here, they want us to solve for y. So we want to get y by itself. So I have 2x minus 2y equals 5. So the first thing I want to do is I want to add or subtract anything that's with on, or kind of on the same side as with y. So we have 2x. And since 2x is positive, we will subtract 2x from both sides, because 2x minus 2x will cancel out, leaving us with negative 2y equals 5 minus 2x. 5 minus 2x. So we do have only y terms on the left-hand side, but we have negative 2 with it. And since we have negative 2 with it, what we're going to do is we're going to divide each and every single term by negative 2, so that y is by itself, because negative 2 and negative 2 will cancel. And I'm left with ay is equal to, well, 5 divided by negative 2, well, that's just going to be negative 5/2, because 5 does not divide by 2 evenly. Negative 2 divided by negative 2 will simplify to 1, and it would be positive, so we have plus x. So we have this here, y is equal to negative 5/2 plus x. And that's all we have to do for this one here. So we're going to look at one more here, and we'll see what the rest of them are. But so here, where again, they just want to solve it for y. So we have 20 equals 8x plus 4y. So if we look at this here, we want to see what is with y that I need to move to the other side. Well, what we have is 8x. So to get y by itself, what we're going to do is we're going to subtract 8x from both sides, because 8x minus 8x is 0. And so what we have on the right-hand side is we now just have 4y. On the left-hand side, we're going to have 20 minus 8x. And we don't combine them because they aren't like terms. 20 and 8x are not like terms, so we don't combine them. So we get this. So we get this here. Now, what we're going to do next is we're going to get y by itself, because here we have 4y. We just want y. So to get the 4 to go away, or to simplify the 4, we're going to divide everything by 4. Because 4 divided by 4 is 1, so we're left with y. 20 divided by 4 is going to be 5. Minus 8 divided by 4 is 2, and we have our x. So we have that y is equal to 5 minus 2x. And that's all we have to do for this here. That's what we need to do to solve for this. Now we're not going to worry about these here where we have more than one of the same variable. But what we're going to look at lastly is kind of rewriting these formulas, solving for a letter. Now the area of a circle, area is equal to pi r squared. And so what we want to do is we want to solve for the value of r. Now we look at this here, there is already a term with r, and that is pi. So what we're going to do is we're going to divide both sides by pi. And when we divide both sides by pi, pi and pi will cancel, leaving us with r squared, because that's the only thing left on the right-hand side. On the left-hand side, we have a over pi. Now we're almost done because we have r squared. Now to undo a square, the power of 2, we have to take a square root. Because a square root and square will cancel out, leaving us with just r. And on the other side, we have a over pi. And that's our answer. So that was a little bit more complicated because we had to do a square root. But other than that, we're still trying to get the variable by itself. Now we're going to do another one here. So the next one we're going to do is, so again, we're going to rewrite a formula solving for h. So rewrite the following h. So our formula is s is equal to 2 pi r. I'm better off just writing this out. Pi r squared plus 2 pi r h. And this here is the surface area of a cylinder. So if we're trying to find the surface area of a cylinder, we use this here. Now the variable we're wanting to solve for is h. We're wanting to solve for the value of h, or the variable h. We want to get h by itself. So the first thing we're going to do is we're going to move 2 pi r squared to the other side. And to do that, we're going to subtract 2 pi r squared from both sides. Pi r squared. Yes, 2 pi r squared and 2 pi r squared will cancel each other out. And so what I end up being left with is s minus 2 pi r squared equals 2 pi r h. So we did get a term on the left hand or the right hand side that does have h. H is here. There's nothing else being added or subtracted to it, but we do have a few things being multiplied by it. We have the 2 pi r because we have 2 pi r times h. So again, since we're trying to get h by itself, what I can do is I can divide by 2 pi r because 2 pi r and 2 pi r will cancel. And since I divided it by one side, we'll have to do it to the other. 2 pi r. Because we do have h by itself. Now here we're just going to divide the whole thing. We're not going to worry about doing each individual term. So I get s minus 2 pi r squared over 2 pi r. Now we could do individual terms and it would reduce a little bit, but it wouldn't be a whole lot more helpful. But this is all that we have here. And this might be helpful. I definitely have this written down. And that's all that we're going to do here for 7.11. So at this point here, go on and start the homework assignment in Big Ideas Math, Chapter 1.71. And that's all we are going to do for today.